Hello there. Welcome to my YouTube channel. So today I'm going to show you how to download ECMWF data. Basically, this is called ERA5 data. So I'll download this data and I'll show you how to create time series from this NetCDF files because one of our YouTube follower requested for this one. So I'm pretty new on this data set. So let's try together. How can I download and create time series? So basically, ERA5 provides hourly estimates of a large number of atmospheric, land, and oceanic climate variables. This data covered the Earth on a 30-kilometer grid and resolved the atmosphere using 137 levels from the surface up to a height of 80 kilometers. So ERA5 includes information about uncertainties for all variables at reduced spatial and temporal resolution. So we are going to download this data at hourly interval. And you can see here, if you just search on Google ERA5, ERA5, basically it's the 5th generation, ERA5, it's the 5th generation of ECMWF, ERA5, okay? ERA5, then you can click there, or you can click there, whatever it is. And see, if you click there on the right side, download ERA5 from Copernicus, and then it will be there, okay? And from here, we'll select, you can select any, you can select from here, because these are the reanalysis data set, and we are gonna download the hourly data, okay? So here, ERA5 hourly data on pressure level from 1979 to present. So we'll have different pressure level from 1 ASPA to 1000 ASPA, and we'll have different variables. So we can even download from here, okay? So let's try. I think it's it'll be pretty good to even try this way. Okay, so I'm clicking on this one, and let's see. Here you have the description, you have everything there, okay? If you click on download data, you need some processing. You can see you have the options, the product type, reanalysis, or ensemble members, ensemble mean, and ensemble spread. You can click all of them, but you won't be able to download all these things because they have a limit to download. So here you can select any variable you want, divergence, geospatial, anything, okay? So velocity and U component of velocity, V component of velocity, vorticity, everything, relative humidity. Sometimes you need the right relative humidity, or we need to calculate that one in order to calculate the evapotranspiration. So for this case, I'm just making it simple. I'm just showing how to download this one. So I'm clicking on temperature, and then you have the pressure level from 1 ASPA to 1000. So for this case, I'm just showing only for 3, because otherwise the data, total number of data will be more than 120K. So then we won't be able to download that one. So I'm selecting this thing, and you have the options, right? The year, I'm just selecting the year of 2020, or you can select any other year as well, or you can select even up to the latest one, okay? 2020 and 2021, because it is going to give us up to present day, up to today, hopefully, I don't know. And then for all month and all day and all time, because it is hourly. And then whole variable, okay? You can select the entire area, the data extension, or you can even specify any sub-region. For USA, okay, I'm gonna select this region like, okay, east minus, okay, minus, what will be the 20, okay? Minus 20 to minus 108. And for north and south, it will be like 60, okay? And then that should be 20. That will cover USA. Okay, I'll show you how to show the plot or extent. And then you have the option format and NetCDF. I'm gonna use NetCDF format, even though it is experimental, but that format is pretty easy to extract. And once you are done, see, you can even submit the form. If you select any other variable or more year, and see, I'm going to show you, still it's working. And if I select even more year here, 2008, still it's working. And okay, and let's see if I can select any other year here, 2017. Still, it's not working because it is mentioning we have more than this number of, okay, 120K more than. So we have to be careful about that one. See, now you can submit the form. Once you are going to submit, so it's going to give you this option, because previously I tried that one And you need to create account there. See, since I already logged in, then they're just processing this one, and they're showing the status. So it is in queued. In a short moment, it will show you in progress. Then it will take time to even show you the download. See, the last one, it took like 22 minutes to show me download. And if I click there, it's like 54.7 gigabyte. So I have already downloaded this data. Okay, I've already downloaded this data and I put it there. Let me show you where I have this data, ERA5. Probably it should be there, ERA5 here. Okay. I have this data, temperature, ERA5, NetCDF file. It's basically the 5 gigabyte. And I'm going to create time series for these stations. Let me open the stations here. I have like 100 stations from 0 to 99. And these are the stations I have. Okay. And these are the location of the stations, longitude and latitude. And if I just want to show you using my GIS, and here you can see the location there. Basically, I'm going to extract the time series for this station. Can you see that here? If I zoom in, it is just locating along the coast of North Carolina, USA. See, so I'll extract the temperature time series for this 100 stations, right? So how can I do that? We have our data ready here, NetCDF, and I'm going to pass this CSV file as a list of a station with their locations. And then I'm going to store everything there within this time series, or I can delete this folder automatically. I'll create that. Okay. So in order to do that, I'm going to use Python here. You can use any programming language, but the logic will be same. You can use even MATLAB. So here, usually I use Spider, but since I'm writing the code for the first time, because I have similar code previously, so I'll just copy and modify everything there. And then I'll show you how to do that, and you can follow this step. So that's why I'm going to use a Jupyter Notebook here, because I can even run cell by cell, and I can see what is happening there. Then I'll just make a complete package of this code, and then I'll run it. Okay. So let's try together. So here I'm going to open here. I already mentioned this one because I tried if it is going to work or not. So what you need, I'm just importing operating system, importing the system, and then importing the projection if you need it. These are the modules you need to even process this data. But most important module you need NetCDF4, and you need to import it as dataset, because this is the method we're going to use. And since I'm going to even do some processing using NumPy array, so I'm importing as NumPy, and I'll do some processing as data frame. So I'm going to import that pandas as data frame PD. Okay. And then I'll deal with dead time. So I'm importing this dead time as well. Okay. And I also need to import directly the dead time, because I'll deal with that one as well. So these are the things we need to import, and this is optional. Okay. The warning, because if there is something wrong, it will give us some warning signal or warning message. I'm going to just suppress this. So this is the option. I'm going to ignore this one. So first, I'm going to read the data, and I'm going to see what are the variables there. Okay. So here, I'm just starting from the beginning. I'm clearing everything, restarting the kernel, and here. Okay. For reading any NetCDF file, you have to use that method, dataset, because NetCDF4, or even you can use NetCDF4.dataset. Then it will even, if you import NetCDF, okay, if you import, you just import NetCDF4, that would be also okay, not a problem. Okay, you can import that way. Then what you have to do from NetCDF4, you have to import and then .dataset, then you can read it. So in order to read any NetCDF file, you have to specify the location there if it is not in the current directory. So I'm specifying the location where I have the temperature ERA5.nc data, NC file, and then I'm reading as, right? Since I'm reading, so I'm putting it as R. Otherwise, you need to provide as W if you want to even write something. So here it is. If I just run it again and then see, we have this object, data object. And if I want to see the variable, so this is the command data, because since it is an object, right? It is an object. The data.variables.keys, it's a function that will give you the variables here. So these are the variables we have: longitude, latitude, level, and EXP, These are the experimental variable. And then we have the time, and T is the temperature variable. Okay. So we'll extract, and let's see what we have, okay, inside the time. We have to know that, right? So that is the option. We can even check the variable time. That's why you need to know the variable, okay? You need to know the variable. If I print and see, this is the time, and it has the unit, hours in 1990 and 1st of January, right? And we have the shape 15,000, right? 15,070 time step. And these are the hourly time step. And if you want to see the time, the values basically, I can't show all of them, but I'm going to show you only 10, first 10. Then it's going to give you the first 10 values of the time. See, these are the times. So this time means these are the hour from 1900, 1st of January of 1900. But we have to specify because our data is starting from the time, right? So that is the hour referencing from 1900. So we have to create that date. We have to find that. So that's how we have to write the code in a way that will create our starting date based on the reference date 1900, 1st of January, right? So we'll do that shortly. And for temperature, let's check that. The variable we want, our expected variable, it has this, right? The scale factor doesn't matter. So see, the unit is in Kelvin, it is temperature, air temperature, and it has this shape, right? First will be the time. Here you can see time, and then you have to pass that experimental variable. And then we have to pass the level. We have to pass this latitude and longitude. Then you'll get, this will be the values or index. Then you'll get the values of temperature, right? So let's see what we have for this one, EXPVR. So this is basically EXPVR. It is dimensionless, and we have the shape 2. And what are the values of this 2 shape, right? So you have to pass this one, means colon means all of these values I'm going to display. So we have only 1 and 5, right? We have 2 values of this. And what about the level, okay? Level, let's see for the level. Because these are the pressure level. I have 1, 500, and 1,000, and it is going to show you this one. We have 3 pressure levels, right? So if you want to even export or want to display the temperature data for one time step, so you have to pass the time or index of the time. If you want to display the data for first time step or the beginning, we don't know when it is going to start. So the index should be 0. And for this first variable, this should be even 0 because Python is 0-based indexing system. And for level, if you want to extract the data for 1 ASPA, you have to pass 1. If you want to extract, you have to pass 0. If you want to extract this data for 5,000, you have to pass the level as 1. And for 1,000, it will be index will be 2. And then you have to pass the latitude and longitude, the index of this one. So we'll find those index based on our location. I'll show you how to do that. So these are the variables. At first, when you have your data, any NetCDF file, you have to explore the variables, their names, their shapes and dimensions, and their long and short descriptions along with their units, okay? Then we can even go for our data. And here, you can even export the unit of temperature. That is the command, data.variables and T and .unit. This will give you the unit of this data is Kelvin. And if you want to see the unit of time, right, it will give you the unit of time, that one. So we'll use this to generate our reference time, and then we'll use that number, this number of hour is from 1900 this year. So we'll find that date based on that number from this year. So how can you do that? I'm just testing my code here. I'm importing the date time here, see the reference date. So that is the function we have in date time. So date time dot, if I specify the date time dot date time, and then I'm specifying the year as integer, see integer year. So unit, I already extracted the unit, right? So now I have this string. So I want to get these values. So I have to provide the index, limit of the index. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and first one is the 12. So that's why it's 12. 12, 13, 14, 15. If you want to export this one, so you have to provide up to 16. So that's why it is up to 16. I'm making it, because it is a string, I'm making it integer. How can you understand that it is a string? So print or the type will be unit, okay? So it's going to give you string, see? So that's why from a string, I'm going to convert it to number, means integer. And then I'm passing that month. That one is the month. So that's the 17 to 19, if you calculate that one. And the last one is the day, right? This one. So that is 20 to 22. So then I'll get that one. So here I'm creating the date time for the reference from this unit. Okay, if I run this one, it will give you the same thing, right? The same thing we got. But this time it is not even string. See, previously it was string, right? The unit was a string. And now, what is the type? What is the type of the reference date? Let's see, it's gonna date time dot date time. So now we have this string. It is not a string, it is as date time object. So we'll use this one. Okay, we'll make the time series. And if I wanna see what is the starting time from this value, right? This is the hour from 1900. So what is the date time if I use this one? How can I get it? If I export all this times here, right? This is the time. And if I use colon, I'll export all the time values, right? All these time values, 15,000 here. All this time values, 15,000 to 15,070 value, right? So let's see, I'm going to export that one. So it's done. And then if I want to use the first value of time, okay, first value of time. So how can I export that one? If I use the times, okay, the times, and if I use 0, that will give you the first value. See the first value. Now how can I get the last one? Yeah, I can get it by -1. It will give you the last value. So this one. So that is the starting time. So we don't need that one. We need our starting time, and we need basically, we need to look through the times and we'll create the date time, right? So we can easily do that. It doesn't matter. So I have this thing ready. I was working on different thing, forgot about that one. Okay, so that's that. And if I want to even really want to do that, I have to create that starting time. So that's why we need to create this way. See here, starting date. I'm going to create the starting date from reference date. I'm adding the reference date and then date time, then time delta I'm passing as hour and the first value of the time. Then it will give us the starting date. Let's see what is the starting date of our data set. So that's the starting date, 1st of January 2020. Okay. And then since I know my starting date, now I can even create the time. And based on the time, I can even extract the temperature value or any variable from this NetCDF file. Okay, that's the trick. I just tested this one. These are the trick I'll use. Okay, if you use time delta and if you pass this time as hour, then you have to specify hour. And if you have day, you have to specify days is equal to 1, 2, 3, whatever it is. If you want to know the date, right, from today or from any specific reference date, or after 30 days, you have to specify days equal to 30. If you specify now, and then it will give you the today's date and time. And if you want to know the date after 30 days, and just use this formula, today plus date time, the time delta, days equal to 3. Then it will give you 3 days, 30 days, whatever it is, or whatever the number of days you have, it will give you the date for that one. So that's that. So now it's time to even create. Okay, now it's time to create our data. So by this time, we know, right? Everything we know. What is our data? We know everything. So I'm just cleaning up everything. And here I'm going to start. Here I'm going to modify everything here. See. Okay. Let me start clean. Okay, here. So what I need at first, I'm just copying the thing I have because it may not extract everything because of the memory issue. Okay, may not. Then I'll use my Linux machine. So here, okay. I'm just explaining to you what I'm gonna do here. First, see, I'm exporting this thing I already told you, and then the output directory. In the same folder I have here, in the same folder, Can you see that? Yes. In the same folder, check all the status as well. Okay. Okay. So in the same folder, right? Okay. Because I have other processes running and I'm checking the status at the same time. Okay, so I have this a location here, and inside this folder, I'm going to create that time series, okay? That time series as temperature_TS. So it will check if this directory exists. Currently it is not, so then it will create, okay? That is the trick I apply. And then I have the station there, right? This validation station sensor pressure level. There, I have this station there. Since the locations is there, I'm specifying this one there as well. Okay, see, it is in progress. I'm just giving you the update that it is in progress. Okay, so I'm reading the file. I'm putting the first column as index, and then I have the station. So let's see what we have. I'm going to print. See, I have this station. So now what I have to do, I have to loop through this station one by one, and I'll create a CSV time name, or CSV file name based on this station, okay? So in order to read this, or in order to loop through this row by row, we can write our for loop this way: for key, comma, value in, and the station DF. I have, this is the data frame, okay? And then dot iter rows, and then you have to use, because there's a function. And if you print, see, if you print the key, it will give you the stations. See, it is going to give you the, oh, no, the index, okay? And if you want to see the value, because the file I have station, the first one is giving this one, because that is the index first column. So for key is the index. And if you want to see the station, the index will be 0. And if you want to see the value of longitude, it is 1. And then a value, it is 2. See, it's going to give you this one, everything. See, that's that. Okay, it is printing. And then this is how we need to loop through each of these stations. And then I'll create the file name. I'll even export this one as well. In order to create any the station, okay? So the station will be a value and 0, okay? And if I want to create the file name, file underscore name, so this file name will be, I'm gonna use my formatted string there. This way, I usually use formatted string, okay? So dot format, and then station, and then if I pass dot CSV, right, I'll have the file name, okay? So I'm just creating the file name first, and then I'll save the data. I'll create the time series and I'll save it. I don't need to print all of them, so I'm putting it that way here. Okay, it will print the file name. I don't need to print even that main file. So here it is. See, it's gonna give you this file name for each of these stations. So we'll save our data, or time series data, using this name. Okay, so that is pretty convenient, right? Yeah, definitely. Why not? So let's do that. So what next? Once we are done with our file name, once we are done with everything, so we have to use our location, right? So we can use our lat. First one is the longitude, right? We already know that. First is longitude. If I use 1, so long point, because it is our location of our station. Long point will be a value 1, and then a lat point. Okay, lat point will be value 2. Now we have our latitude, we have our longitude, we have everything, right? Everything is ready. Then what next? Once we are done with latitude and longitude, so we have to export our data, right? And we can even export this data this way, the variables we need. What variables we need? We need our latitude, we need our longitude, we need our time, everything, right? So I'm gonna just copy this line, and when I'm reading, then I have to read our NetCDF file. See, here is the line where I'm reading our NetCDF file. So I'm exporting all these times, okay, this way. And if I wanna even export the latitude, I have to use this one, variables, and then I have to pass latitude, okay? Let me check the name of the variable. It should be the exact name. That's why you need to even, it's better to copy the latitude other than just writing, otherwise it will create problem. It's done, and I'm copying this style and longitude, okay? Long, and then I'm gonna copy the name of the variable. Each time I do, I just copy the name so that there won't be any problem. So here is the longitude. So I have all this latitude, I have all this longitude, everything. Once everything is ready, then we can even use our main code, okay? We have, and then what we can do, we can even export the unit, okay? The unit we need, the unit, because it will be necessary to use the unit, we'll use that unit. And here I'm gonna use the unit. This is the unit of time, okay? That is the unit of time. And I'm gonna even use the unit of our temperature. That is necessary. And I'm gonna give this as T, okay? The unit of temperature is unit T and unit of time is unit. So because we are gonna use that one as well. So now it's time to even loop through this one. So I'm done with this step. Okay, I have the station name, I have the point for my station, this step is done. Now what I have to do, I have to create, because now I know the location of my station, right? This is the latitude and longitude. So I have to find the closest point from our NetCDF file using this latitude and longitude. How can I do that? So I can make I can make a difference between all of this latitude and from my latitude, and in between all of this longitude from that NetCDF file, and because I have to use colon there, then it will be all of this, okay, this way. So if it is done, then I can do that, right? So I have all this latitude, longitude. Then how can I do that? I have sample code here. I tried it previously, so I can use, usually what I do, I use this square difference, and I'm gonna just copy this after this one. Then I'm gonna explain it to you. Here it is. These are my previous code. I use the same notation. So a square difference. So I'm making another basically array called square difference latitude. Then the latitude of that latitude from my NetCDF file and my lat point here. It will make the difference, and I'll square it because there will be some negative, positive value. So the square difference will be the value. And then for longitude, same it will do. So now what I'm going to do, I'm going to find the location, okay, index of the minimum. Now I have the square difference. So my point, this location of the station, that will be close to any of the data point I have. So that's why I need to know the index, right? So this array.argmin function will give you the index of the minimum value between this difference. So that is pretty, and if you want to even extract the maximum index of the maximum value, you can use argmax function that will give you the index of the maximum value. So it will give you the index of the minimum value between this difference. So why we are gonna get the index of the minimum value, because the point, if I take the difference, the point close to my point, right? Because we may not have the value of the temperature for my point. I'm gonna even export, right? I'm gonna like this way. We have this because these data are like graded data this way, right? These data are graded data this way. So I have a point, for example, here. So I'm gonna make a square difference in between this point, this corner, and my point, this point and my point, this point and my point, this point and my point. Then I'm making it a square, right? Then I'm creating, see this, this distance between these 2 points will be minimum. So I'm considering this point as my point to extract these values, because that data set may not have value for my point. If my point is on that point, on that corner, on that grid, then definitely it's perfect. Otherwise, we're just considering this one. Okay, so that is the idea. We have the gridded data. I'm gonna select the closest point as my point. So that is the trick I'm applying here. Okay, so when I'll get the, wait a minute. So when I'll get the index of the minimum value, that means I can use that index to export the data, right? I need. How can I do that? So that is the option. And before importing that, I need to create the time. Okay. When I'm done with that one, I'll use this thing here. See, it's another way to. So now I'm gonna generate, okay, this line. So I'm gonna generate the time series for that station, for each station, because I'm looping through each of this station. Then, right, I'm getting the location of that station. I'm making square difference between that station location and all this latitude, longitude. I'm getting the index of the minimum value, means the closest point on the grid. Then see, I have the reference time because I use the unit, same thing I'm using here. And then the date range, I'm creating an empty list and the temperature data that I'm gonna extract. Since I have the times, right? I already exported all times here. I have 15,070 values of hour from our reference time. So I'm looping through each of this and I'm making the time, date time, okay, here, date time. So the date time will be the reference date. From the reference date, we already know reference date here, right? 1990, 1st of January. And then date time, time delta, and hours equal to integer of the first value of the time. Because when I'm using this enumerate function, it will give you the index and the value. The time is the value of the first value of the array, right? The times, the number of hour. So I'm adding it, so it will give you the date. And I'm just adding this to the empty list. That is the command append, and I'm just appending these values. For the temperature data, I'm exporting this, the temp. I have to use this value here, temp. Okay, it's time you need, or you can even, I need to export my temp variable, all temp without unit. If I use colon, it will give you everything, okay? So I have the temp. So I'm using that temp because it is 5-dimensional data. So it needs the index. First index should be the time. So here, the first time index, it should be the 0. And then I'm giving the exp here. It should be 0 index, first value. And I'm exporting the temperature for 5. There are 3 levels of pressure. 0 SPA, 500, and 1000. So I have 0, 1, and 2. So I'm gonna export the surface temperature. That is the 1000 SPA. And then minimum index of the latitude and minimum index of the longitude. Then it will give us a value for that first time step, 1st of January 2020, and then first hour, because we have data for 20 of 4 hour, right? Hourly data. So it will add there. So it will create empty, it will fill up, it will populate this empty temperature data, and at the same time, it will populate the data range or the date range, right, for our first time period. So that is the trick. And when I'm done with that one, let me just quickly show you. It will print. I'm just show you before saving it to NetCDF file, the date, okay, date range. Let me print it if it is gonna cover. I don't know, maybe it is gonna show you the out of memory because it is gonna do all this processing and it needs a lot of memory because it is huge data set we have. So it's reading everything and it is doing everything possible. Okay. So when we are done with that one, theoretically, so what we are gonna do, we are gonna save. Okay, we are gonna save our, since we have our date range, we are gonna create a data frame, empty data frame from this one. Okay, I'm gonna give the name date time, and I'm just making this date time as index. So that is the option, date time.index, it will give you the index. And then I'm adding when it will populate, right, this temperature data, and I created the date time from this date range, and then I'm adding it to that DF, and I'm giving the temp. And then that's why I'm using the temp, and then the unit will be there. Okay, the column name will be temp, and inside this parenthesis, it will give you the unit of this temperature data that I used here, unit T, okay? This unit T, that will give us the K, Kelvin. And then that is the command df.csv, and I'm saving it to my output directory. That's why at very first moment I specified this out D right there. If the directory exists, then it won't create, otherwise it will create. So that's that. So we are done with this one, okay? So it will save that. And if you want to even plot, if you want to plot this data, we can do that because I have similar code. I can even show you this one as well. Usually when I export any data, I even plot it. So here, right? I'm just plotting this one, title, temperature, atmospheric temperature at that station. That will be heading, and then I'm using figure. And for that one, you need to even export that matplotlib as pyplot, okay? You have to even import that one as well. Then it will plot. And if you want to even see matplotlib inline, or okay, we don't need that one, okay? We don't need that one as well. So it's taking too much time. Maybe it's gonna show you out of memory or something like that, because it needs a lot of memory and calculation. It's gonna do this thing for you. Okay, so it is gonna save everything there. And if not, see, it's created already that output file, and it's empty because I even didn't run this file for this one. Okay. And because if I run this code in Linux machine, that's why I put it there. It will just show you the plot for 2 seconds, and it will then close automatically. Then it will go for the next one. And these are the normal plot, if you already know, right? I'm plotting. I'm just declaring that figure size, this one, the A4 size, and then I'm just declaring the title. Here is the title, and then I'm making this X level, time zone, and then the Y level with the temperature, and then the unit, and I'm specifying this tick param, the size, and you can change it. Okay, so it's gonna show you this error, maybe unable to allocate 21.8 gigs. So that's why I'm gonna run this same code in my Linux machine. I'm gonna show you that one. So then here is the code I have. Okay, so same code I have here, but for Linux machine, I have to specify the output directory as this one. And here is the data I have. See, I stored this data there, ERA5. Let me find ERA5 temperature data here. See, same thing. I'm gonna delete that one. So I have this data. I have this location of my file. Okay, same file. It's the same one. And then that is the code specifying and data set I'm reading. Everything is same. Everything is same. See, there is nothing different. Everything is same. And then it will show you the plot and it will save. Okay, let me just run this code then here. In order to run it, okay, since it is Python, you need this one and ERA5 maybe. Okay, that is the name of the script. I'm gonna run and it will show you the temperature plot and everything at the same time. So this is how we can even export. Okay, let me show you, or I'm gonna even, if it is gonna work, then definitely, yeah, it should work. It's reading, it's running. Maybe I don't have processor empty. Let's check if it's gonna run or not. Definitely it's gonna run, otherwise it will show you the same error. Because it should run, because I run this code for even more than this data set, this memory, because this PC, Ace PC, I'm running this on my Ace PC, and this Ace PC has 256 gigabyte of RAM and 64 processor. So it should definitely run. There is no alternative. Let's check if it's really gonna run or not. It should run. Okay, see, it's generating. Okay, it's generating, and see, it's okay, it's creating the time. Let me just switch my window. Okay, let me switch my window, and I'm gonna share it again. So on that window, see what it's gonna create. So that is the plot it's gonna create. See, every time it's plotting, and it's creating that way. Can you see that? Definitely. This is the temperature for each of this file. It is creating, and it's showing this message. That's why I usually extract and plot. Okay, I'm gonna switch again because I have 3 different monitors. So I'm processing this one and it's plotting there. And if I can switch back to my previous monitor, see, still it's running, it's plotting and showing. And what it is creating there, let me show you the output directory ERA5, right? It should be temperature there. See, it's gonna increase this number there. See, one by one. See, one by one. It's saving all this CSV file and it's plotting. So this is how I can show you what it is generating as. See, this is the time series we have from 1st of January and temperature Kelvin, and that's it. See, it's huge because we have the hourly data. We have 15,070. See, 15,070. Since it is 71, it started from the header. That's why we have this one, and we can plot it here as well. It will give you the same. Okay, if I want to plot it there as well, if I want to plot here, it will give the same type of plot. See, here it is. Here it is. It is going to give you this one, but that plot is not that good, right? But it's similar to that one. Okay. So that's it. So this is how we can even download that ECMWF data. Okay, ECMF. What is the name of this one? ECMWF. This is the ERA5, because basically the 5th version of this one, and then you can use Python code, the similar code I just demonstrated here. You can use this one to extract time series or any station you want within your data range. You can do that. Okay, and if I want to even plot, okay, if I want to plot the spatial extent of the data, let me show you that one quickly. Then you'll be able to understand what I'm gonna told you. The spatial, okay, the spatial location. See, I'm gonna show you this one, the data I have here. So I'm gonna plot the temperature. So it is gonna show the aerial extent, spatial distribution. See, it's gonna cover, right? It's covering the entire USA, part of the USA, and you can see that. See, from this, I'm just exporting this data from this location because this is the North Carolina here, this location. Okay, so that's that. If you wanna download and export this ERA5 data, you can do this way, and that's it. So I'm gonna finish up here, and if you like it, or if you have any query, you can ask. I'll try to answer your question. Otherwise, you are done here. Okay, thank you very much for watching, and thank you very much for supporting. Okay, bye.